Hello everyone, this is Jayant from JBTech INDIA, and this is my second video on how to create a test bench. So as on the first video we had seen how to create a Verilog file in Xilinx IC design. So I'll be opening the window again. So earlier we had created the half adder. Suppose this was it. This was the half adder that we had created, and we had gone through the RTL schematic that had been created. This happened to be the RTL schematic that was created. So what we now particularly want is that we want to simulate our design basically, because we want to check whether our design is working or not. So for that we need to create what is called a test bench. So the following steps follow on how to create a test bench basically. So a test bench is also nothing but a Verilog file only, a .v file, but with a little different syntax. And these both files, your design file and your test bench, are linked to create a final simulation. So for the sake of this, what we'll be doing right now is that we'll be right clicking on your project and we'll be adding a new source. But this time we won't add a Verilog module, we'll be adding what is called a Verilog test fixture right here. So I'll be giving it a name. I'll be calling it some test1, and then I'll click on next. So, and here you are choosing the module particularly for which you want to create a test bench. So this right now happens to, what we have here is only the half adder that we have created, but your design can have multiple modules inside. So this window is particularly important because it links your code to that particular module, means what test bench you want to create your module for. So here as of now it is only HA, so I'll be clicking on next, and that's it. So what it has opened right here is a window, a small test bench window. So the good part is that it is not a blank window. There is some pre-created syntax straight away, so we don't have to create much of a syntax. So there is a test1 module declared with the inputs passed, and as we can see, these are the same as the inputs of the half adder, like A, B, S and C, A, B, S and C, and they are linked to the half adder. The inputs A, B, S and C are linked to the input A, B, S and C of the half adder. So this is the part which we'll be interested in, like passing the inputs. So here I'll be giving my input A and B equals, this is the concatenation operator to be specific. So instead of writing A and B separately, I'm writing A and B as a single argument itself. So I'm writing A, B. So both A and B are single bits in individual, but together they would be like 2 bits. So A and B is equals to 2 tick B 0 0, 2 times 2 bits of binary. So and both 0 0. So I'll pass one value and I'll wait for some, let's say 10 nanoseconds, and then again I will call A, B, but this time some different value, to take B 0 1. It means A is 0 and B is 1. I'll again wait for some 10 nanoseconds. That's it. And this input I will give the input as 1 0, which means A is 1, B is 0, and then I'll give both 1 1. So we have created a small test bench, and what is happening in the test bench is that for 10 nanoseconds I'm giving input 0 0, and for another 10 nanoseconds I'm giving 0 1, then 1 0, then 1 1. Basically I'm giving all the combinations for A and B just to check out. So now we won't be interested in the implementation part because that has been done. Now we are interested in the simulation, so we will come up on this side, simulation. We'll highlight this, and then our top module, the test1, and then there is this ISM simulator. Basically it is the ISM simulator we are using to simulate our design. I will expand this dialog and then simulate the behavioral model. So you will save our project. Here is the command log running. That's it. It has opened the ISM window. So the simulation has finished. So what we have in front of here is the simulation window. As we can see, here are the inputs S, C, A and B, their values currently. So it has run up to some like 99999 picoseconds. So total simulation time that we have run on, but what we were interested in is only for some 40 nanoseconds. So this is the complete simulation window. So we'll be means like zooming out a bit. I'll fit to the screen. That's it. This was the part that we were particularly interested in. I will just zoom this part, and means like we can cross confirm, like when A and B were 0 0, the sum happened to be 0, the carry was 0. When A was 0, B was 1, the sum was 1, carry was 0. Similarly for this part and this part, and verifying it proves to be logically correct. So we have created like a test bench for our half adder that we created, and similarly you can means like create any test bench for your particular designs.